You got how many?
I got all of them right.
Let's go, baby. That's what I'm talking about. All
I
right.
think I got like 6.
So.
He wants to show me what he brought for his birthday.
Oh yeah, look. Ashley, look behind you. All right.
No way.
His backpack's in my backpack.
No.
Marley, you want to see mine? So,
I brought it.
question 15 on multiple choice.
Oh, let's do.
That's so fitting.
Bro.
Wait, did you bring the shopping cart too?
No, shopping cart's Deacon's. Being forced to leave it in the
What
back.
is that?
That's a good
This
one.
is a meaningful.
Okay,
Is
I'll
your
send it
stuff
later.
there too?
Yes.
That's so funny. You did ball.
Said what?
I agree.
We are too old for this.
No,
we're not.
No, we're
You are
not.
really old.
There's no weed, dude. You're
What's calling in this shopping
Have you ever
cart?
heard of fun?
Yeah, I don't think it's.
We're turning this into like, this ain't Hillcrest, it's Barstool, bro. This is the last week of school, high school ever. We're gonna have fun. So, number
We gotta go on
15.
Barstool now.
As I told,
You ain't paid the school
excuse me,
guys.
hey, one, cell phone's
I
up.
said 15 on the 85 sign.
Oh, on the probability
Oh,
one?
you got everyone right.
Got it.
Hey, I was gonna email this.
I thought you said 22
Yeah,
out
I
of
guess
23
not. I
originally.
guess not.
right.
Club 30.
Hey, bro, guess what? Quickly.
It's good that you don't have to be here, Tyler. You can just,
Just get everything.
Oh,
I got
I
21, so does that like excuse me to go get pushed down the hall?
No.
Dude, actually, later he's pushing down the hall and I'm gonna hold my fucking charger.
Flex.
I mean, no, I'm not.
Yo, no one got in the baby seat.
Oh, yeah, bro. Wait, what? God, I don't want to share with you.
Yeah.
Really quick.
This will not take long.
Oh, you have a video?
I got a photo of it. Like,
Dog.
I sent that over.
Are you gonna
I think Levy has a video. Bro, send that to me, bro.
What is this one thing about that?
She closed the door.
Lawyers.
She was talking to someone in the hallway and she just slowly.
So we have 5 of us who finished the probability distribution review.
He wasn't
That
there.
means quite a few of us still need to.
Is it 15?
Okay, so,
I mean, like, you know, if you bring it back tonight, it'll be fine.
I'm gonna put it on eBay, make y'all bid for it.
alright, so this question that Tyler's asking about, 10% of all Dynamite mint candies are orange and 45% of all, holiday mint candies are orange. 2 independent random samples, each of size 25 are selected. 1 from Dynamite mints, other from holiday mints candies. Total number of orange is observed. What is the expected total number of orange candies and the standard deviation for the total number of orange candies in the 2 samples? So when I think about this, one, it's asking about expected. What's another way to think about that term expected? Average, right? That's going to be the mean. And how many distributions do I have? 2. So I'm going to look at the mean for the Dynamite mints. Adding or subtracting? Adding, right? So it's the total number, right? So plus the holiday mints. And what do we know about adding 2 distributions? You're just adding their means. So I'm going to come back to that in a second. And then it also asks about the standard deviation, right? Standard deviation, we're also adding. So it's just the standard deviation of Dynamite mints plus the standard deviation of holiday mints, right?
The variance.
Say it again.
The variance.
We cannot forget, you cannot add standard deviations, you can only add their what? Variances. So we just need to recognize I have 2 distributions. As soon as I see them talking about 2 different distributions, right? And we have independent random samples of 25, and we want the total number of orange candies. Now, how am I going to find the average number of Dynamite mints if 10% of all of them are orange and we have 25?
21.
So 0.1 times 25. Notice that's just n times p. Because we also need to recognize what type of distribution is this. Each distribution is what? It's what? What you think, Joseph?
Sampling.
Not sampling?
Is it
It's either orange or it's not.
Oh, yeah, it's by no means.
It's binomial. And go look at your formula sheet. See if we can remember what type of distribution it is. If we can identify the type of distribution. So everyone should have a formula sheet out for everything we do over the next 3 days of class.
2.
3 plus Tuesday morning / 2 plus Tuesday morning for Joseph and Deacon. What's up?
What's it supposed to be here Monday?
Yeah,
Oh,
this
no.
will come Monday.
Yeah.
Dog, you got an AP exam on
Only
Tuesday.
for
Come
this.
on.
class.
If you're a senior, do you have to be here?
Yeah.
No. You have an AP exam, show up.
I didn't know I was supposed to be here Monday.
I would, I'd take right
And
now.
it's not like you have to.
Hey, man,
Wait,
what are we doing?
Right.
What are we doing Monday?
Reviewing for the AP exam. Alright, look. When you look at that formula sheet,
Don't.
we're talking about probabilities, right?
Save
Get the
gas.
formula sheet right there. We're talking about probabilities, right? Do you see anything about the expected value for a binomial distribution?
Yes.
It literally has the mean on there, doesn't it? And what does it say the mean is? N times P. And I'm going to tell you this, a lot of times for that average is not as hard to remember, but it is a little bit harder to remember maybe for the variance, right? So we can only add the variances, can't add standard deviations, and we have to recognize, hey, I'm combining two, so I'm just adding their means, but I now need to recognize, hey, it's binomial, so N times P for 2.5. For the mean of the holiday mints, again, it's N times P, but it's 0.45 times 25. It's a little under 12 and a half, right? Maybe 12? I don't know.
13.75.
Total of 13.75, so this must be 11.25. Just doing the math off of those answer choices, right?
Okay.
But all you have to do is pick up that calculator. So we're down to C and D. Or C, D, and E, thank you. C, D, and E. Now, for the variances. How am I going to calculate the variance for a binomial distribution? Notice you're on sampling distributions. We need to be thinking about probability. Yeah, what is the standard deviation formula though?
Square root of NP times 1 minus NP. Or I guess P complement.
Yep. Or the complement of, yeah. But if we want the variance, do I even need that square root?
No.
So it's literally just that 25 times 0.1 times 0.9 plus,
Oh yeah, I just squared it in the second step.
yeah. Okay, so what do I get when I add those together? 'Cause I don't have a calculator on me. I definitely don't know that off the top of my head.
What? You're supposed to.
Oh, heck no.
375.
How
You're
much?
supposed to know everything.
375.
There's no way to know everything. There is definitely a way to learn more though. 8.375,
4375.
4.375. And so what do I need to do to find that standard deviation?
Square root of that.
Hey, square root, my guess is it's going to be D.
Yeah, it is D.
Yeah. I just know that because it's close to 9, right? And the square root of 9 is 3, so I assume it had to be close to 3. Does that make sense though, Tyler? Like those pieces coming together on that?
Yes, sir.
So again, two distributions, we want to recognize we need to add their means. Two distributions, we need to add their variances, right? Notice if they had asked for the difference, the only thing that would change is I would subtract here and I would subtract here, but would the standard deviation change? No, right? We only, variability, chaos only increases, so we would add their variances still. And again, we have to be able to recognize what type of distribution each one is. Do notice, does it tell you they're normal distributions? They don't, because are they normal? No. They are what? Binomial. Whenever I see anything like this, and it's orange or not, I think about binomial or geometric, one of the two. Yes, Logan?
There was one of the questions on there. I forgot which one. I think it was one of the older ones. It was like, wow. My chose E. It was like not enough data to like.
Say that one more time. Sorry.
It was one of the earlier questions on that one.
Okay.
Not enough data to support an answer. That was an easy choice. Forgot which one it
I do not see it so far.
You might look at that.
You think it was one of the early ones?
Wait, no, it might be like actually.
If I can't find it, look for it and let me know. Because I might have just accidentally skipped it, so go ahead and get your iPad out or something to look. Yeah, I definitely don't see it. Alright, so again, we got a couple days of class. If you find questions that you need to ask questions about, which probability is one of those sections that I think was the hardest for some of us initially, but we learn, we master, we grow, and we can be okay, because my guess is it's going to be around 15% of the exam. It could be anywhere from 10 to 20%. And so we don't have to know everything, but we do need to be able to recognize some things. And if we can recognize it, it's easier, right? If we recognize conditional probabilities, if we can recognize union, so the probability of A or B, we have formulas for that. We need to know how to check for independence. We need to be able to identify binomial and geometric and normal probabilities, things like that. If you can name it, it makes it way easier to tackle. Vocabulary is important, so if you can name it, it makes it easier to tackle. So make sure that you use your FAIR models. We're about 4 or 5 days out. A single page or 2 pages to summarize a chapter or 2 from a textbook is really useful. Pour through those, see what questions you need to ask, but let's do some free response questions to help us review at this point. So I gave you the 2022 free response yesterday, I believe.
No, you do not.
You do not.
I did, but if you weren't here, you did not get it.
He definitely did.
With those extras. Oh, I also have something. This is not something you have to turn in. Yes, sir.
Yeah, this morning.
Come back after Come get it. So back Hey guys, this is not something you have to turn in, but this is something that Deacon was asking about if we could have it. It is a FAIR model for chi-square, and the backside is inferences with slopes. Again, don't have to turn it in, but this can help you study for the chi-square if you want. I will still do solution sets for the chi-square notes so that you can use that to help you study as well. Now, a quick note about this is the chi-square is only 3 to 5% of the exam. However, I have seen it be a free response question. So it may be something that you still want to study. Like, I would say once every 2 to 3 years. So it's not that infrequent that it's a free response question. And it wasn't one last year.
What's the probability?
Well, if it was, so what's the probability of being on this exam given it wasn't last year? That's significantly higher. Granted, probability is all long-term probability, right, in the long run, so who knows? All right. I don't know. It depends on how you define it. All right. Right here, oh, free response, I need to pull that up.
And print me out.
Oh, thank you. I already have it.
So the rest of my
No.
life, absolutely not.
Absolutely, yes.
Oh, he says it this time. I know where you live.
Not after today, you won't.
Oh, I have Jaden. I have Jaden. He'll figure it out.
Yeah, creepy student that he is. You probably will try to figure it out.
Jaden probably knows where every teacher lives. I just have a feeling.
Yeah.
I know where Jaden lives. You want to know?
I also know where Jaden lives.
I know roughly where Tyler lives.
I know exactly where Tyler lives.
It would take me a while to find my way back there. This- I'll just have to reprint it for you. I have extras, I just don't know where it is. Wait, did I find it? I found it! No, just kidding, that's 2023.
Oh.
I
I
lied.
know where Leah lives.
Are
Alright,
you sure?
Probably don't remember it, but I know the general area.
alright,
Are you
Leah, it is
sure?
printing out on the back counter.
After we're done.
Alright, I want you to take,
30 minutes.
let's say 11 minutes to do the very first free response question, then we'll go over it. Okay, so 11 minutes,
Is this
Hopefully this-
2022 and 2023?
just 2022 right now.
Alright.
Just 2022 right
These are the
now.
only two that have.
I only have this one.
It's the question.
Talking about the biologist Gabby.
Yeah.
It's my actual backpack.
Out.
Well,
Tyler, can you
it's-
please put that
Some
phone?
of the things said, do not erase, don't waste your time erasing, cross it out.
That's why I said-
Arrow.
If you have time, erase it, but cross it out for sure. Yeah. Because they will score your lowest response.
These are douchebags.
So we have a.
Well, if you have conflicting, by the way, I caught that on film, thank you.
I mean,
if-
I said it.
I'll own it. If you have conflicting responses, the incorrect response reveals that you don't have full understanding. So that's why that happens.
Yeah.
Alright, so based on the scatter plot, describe the relationship between mass and length in context. So what things will you need to write about for this to get credit for part A? Strength.
Direction,
Direction,
and it is linear.
okay, so
And-
strength, direction, shape.
Unusual aspect.
Are there any unusual aspects? And context. So let's see what they had for us here. Their response was, the scatter plot reveals a strong positive, roughly linear association between the mass and length of bullfrogs, right? There are no points that seriously deviate from the straight line pattern of the points in the plot. Notice the beauty of, and this is a new thing with the AP exam in the last 2 to 3 years. How many of components 1 through 4 did you have to have? 3. So you only had to have 3 of these 4. Try to get all 4 of them in case they change that up in the future. But then you had to have context. Which of those do I need to explain better?
So if I miss unusual features, but I get all the other ones, it's still an E?
As long as you had the correct direction, positive or increasing,
Yep,
the correct strength,
yep.
the correct form, and the context, you're an E.
What if we said
I'll
strong?
make sure I'm
Hold on, I can only answer one question at a time.
How do you define a context?
So just right here, so the scatter plot reveals a strong, positive, roughly linear association.
Oh.
It's a linear association between the explanatory mass and the response length of the bullfrogs, right? Or just between mass and length of bullfrogs. Oh, it's length and mass.
I thought it said slope and slope in the equation.
Well, we haven't done B yet.
No, I thought for A, it said slope.
No, because
There's a whole other.
where's page 1?
It's not page 1.
Dog, that says B right there.
Oh, shoot.
They gave me a survey
Should
last
be.
week.
Where's page
It's on the
1?
back of the front page, right here.
Dog, no shot.
Shot.
You guys stay on the
Yes, shot.
There's always, it always starts with part A, by the way, guys. Make sure you look
I
at
assumed
part
that was.
A.
If
So-
it has the picture, I assumed it was.
No, alright. So part B,
Well,
I
I got this.
You're probably like,
hey, excuse me. Hey, guys, I can't hear Josh and he's right here, which means you also can't hear him and learn from what he's asking questions about. So let's focus, thank you very much. Alright, what are you asking, Josh?
So what if you said strongly linear?
I'm assuming that they would accept that. You're indicating strength and shape, right? It's just traditional to say a strong, positive, linear relationship. It's traditional to say strength, direction, and shape. They always will do it in that order.
Alright. As long as you got.
I'm trying to think about it. I would adjust it to say strong, positive, linear relationship, because they might accept it, but I could just see them being weird about it.
I think I still got 3 out of it, because I said positive, strong, linear, context.
Yeah.
I did say those are potential.
Wait, do you have to do it in context?
Yes. Yeah, so be careful about that, because I will say, were you thinking about this one?
Yeah, that's why I said potential.
So maybe if you say that, maybe circle it. I wouldn't think that's far enough away, but, I could see them accepting, let's see what they said in the rubric, cause
Well, I
sometimes,
did say about wood, like about 160 mm or 350 G.
Yeah, that's what I did. I said with one to no glare outliers.
So
The
there
two outliers,
maybe
one
actual
actual
potential high.
yeah, that's what, and that's why I would just make that clear. I wouldn't have thought as far enough away, but I can see someone making that argument. Alright, part B, Deacon's favorite, cause no shot. Part B asks us to identify and interpret the slope of the least squares regression line. So first off, right, Aaliyah, what is the slope of this least squares regression line?
Right there with that arrow.
This least squares regression line, what's the slope?
The negative 536 plus
Okay, but which part's the slope?
the 6.9.
There we go. So that's an a plus bx. Explanatory is length, slope is b, y-intercept is a, right? So make sure we pay attention to that. You don't have to, but what was the thing I would highly recommend to help you interpret that slope correctly? Because
For every blank increase.
so 1, put it divided by 1, but there was something else, and we're going to get to the actual interpretation, but I'm talking about the setup to get to the interpretation.
The change.
The change in predicted mass, because it's the change in y divided by the change in x, right? So change in, so you don't have to, but I promise you that if you practice doing this, it will make it next to impossible to not interpret correctly. And then same thing with the y-intercept. The y-intercept is always a 0 comma the predicted y, right? And so almost impossible to get incorrect if you put the context with it of predicted mass, right? So when the length is 0 centimeters, the predicted mass of the bullfrog is negative 546 grams. And Josh, is that realistic to have a bullfrog with negative 546 grams?
No.
No, what's the issue? Why would we get such an unrealistic number for the y-intercept?
Oh, well, that's extrapolation.
It's
I was about to
extrapolation.
say it didn't have
I know, I was just pointing out if it asks for that, that's what we're talking about. Alright, so let's look at their rubric. Evaluate yourself, see if you need to ask questions.
E for excellent.
So, as long as some way, in some form, you identified the slope as 6.086, you would get that piece. Notice you had to have all 3 of these components though. You need an interpretation that references an increase of a number of grams of mass for each 1 millimeter increase in length, right? So make sure you have the grams and millimeters in there. So for every extra 1 millimeter of length for the bullfrog, the mass is predicted to increase. Notice how they clearly have a length, like a whole component is that the y does not increase, but the predicted y, the estimated y, the expected or the average y
So you could lose
increases.
out a point just for one word.
Uh-huh.
Yep, you can.
What changes the meaning of
This-
what you're identifying?
That's exactly right. It is changing the meaning of what you're identifying. Because when we say predicted or estimated, we are talking about the least squares regression line. If you just say the mass, what you're talking about is the actual individual points. Hello? Yes, ma'am.
That might be good.
That camera's just fully getting our faces.
He fell against the door frame. He never fell down.
What?
Oh, it?
Felt bad.
Yes, ma'am.
I didn't hit with my board.
Yep.
I've never done that.
I had to get Eunice to walk.
Not yesterday, but he was here
No
today.
one would hit the bar.
He was here today.
I had to get Eunice to walk behind my board.
It was 2 days ago. It was either Monday or Tuesday. Correct. He was back today. Yes. Yes.
We're gonna push it
Right.
around.
I
Supposedly they banned it.
I'm over there sitting. What are you actually gonna roll on? I see.
Yeah. Thank you.
Yeah.
I realize that
Alright, so, similar, hey guys, does anyone know another case within free response that almost always shows up that if you do not use one word, it automatically loses you?
Written process, when I don't use unique.
Yeah, you gotta talk about unique or without replacement on assigning or sampling or something like that. If you don't use that word unique or say you're sampling without replacement or assigning without replacement, you're automatically losing one of those components and going from an E to a P.
Predicted.
The predicted, right? So the predicted mass of a bullfrog. Okay, or something like that. What were you gonna say, Lexi? What were you thinking about?
I was thinking about approximately normal. Would you?
Yeah, so that is actually a good point. Are we ever gonna call anything normal?
No.
No,
Not really.
nothing is normal. It is approximately normal. Nothing's truly normal, right? No, just like there is no true perfect circle.
Although I think sometimes on the AP exam, they'll just say they have a normal distribution.
They will, but we don't say that ever. I think almost every time I've actually seen it's been approximately normal. All right, how do we do on B here?
They don't ball it out.
We balled out. We understand. If we made a mistake, do we understand how to fix it? Okay. So by the way, guys, score yourselves on this to see what you would have actually gotten on this free response question. All right, C. Okay. This is something we gotta do because this is showing up on more and more AP exams. What is the general format for when we're interpreting a coefficient of determination?
Say AP.
X%.
You're talking about a residual. That's how we calculate a residual. This is that R squared, the coefficient of determination.
So it's like blank percent of the variability in Y is accounted for by changes in X.
Okay, so you can say that, right? The 81.9% or the proportion of 0.819 of the variability in my response variable, the Y, is accounted for by the association with X, or the least squares regression line with X, or the association between X and Y. Any of those things will work. So
Would
it's-
the same changes in length of bullfrog work?
Let's check the language from the rubric in just a second. I think so. Austin, did you have a question?
Yes, so I forgot like the format. I don't think it would, but I was make sure. Would saying just like the coefficient determination of the least squares regression line of in a context is 81.9%?
Is what?
81.9%.
No, you gotta interpret. Interpreting a coefficient determination, guys, is the percent of variation in the response variable, the bullfrog mass, that can be explained by the variation in bullfrog length as described by the least squares regression line. That's the technical perfect answer. You didn't have to have exactly that language. Notice it just it literally just says a correct interpretation of R squared in context. I hate that. They have additional notes here though, right? Proportion of total variability in the response variable that is explained by the independent variable. So if you had context with that, Josh, that's correct. Is that kind of how you were wording it? You were wording it like this top one? The percent or proportion of total variability in the response that is explained by the independent variable X?
Yeah, I'm saying like 81.9% of variability in massive bullfrogs is accounted for by changes in length of bullfrogs.
Yeah, I think that, yes. Notice any of this language here, guys, proportion or percent, but when we say coefficient determination, it's the percent of variability in the response variable that's explained by the, or accounted for by the explanatory variable, or the relationship between the explanatory and the response. The linear relationship, something like that.
So essentially, correct.
Yeah.
Can you scroll up so I can see what they put?
Yeah. I will say this, I don't love the way they worded it, but I just don't love, I would just say it can be explained by the relationship with the bullfrog length. Something like that. How are we feeling?
Spectacular.
I'm glad to hear that, Deacon. He's looking spectacular today.
I'm gonna get rid of today.
I can tell you complained a whole lot less than normal.
Because you got to bring
I got it all out.
It's kind of like the project is like 30%.
So Miss Moore is in upsetting spaghetti this morning because of you.
Actually, I didn't like calculus either. I was still pretty good there.
Alright,
Probably because of your shenanigans.
On the
Yeah,
project.
she was getting mad at that.
so let's look here at D. Based on the plot, approximately what is the length and mass of the bullfrog with the largest absolute value residual?
So probably about 162.
That's
So which one are we looking at here?
That little bottom
Bottom
one.
one around 160.
That one.
Right?
I put 162 milliliters.
So now it asks for length and mass. Did you put that?
I put 355.
So a length of 162 millimeters sounds good, with a mass of, yeah, let's say 355.
So you
Now,
can do a
let's-
little bit of estimating.
I was gonna say, let's just say that though, because do we know it's 162? So length of, or we could say an approximate length of, approximate length of that with an approximate mass.
Predicted
I
mass.
put
Oh,
162.
That's a great question. Let's listen to that, because I was gonna ask that question. Can I say predicted mass here?
No, because it's the actual.
Because it's the actual, it is not predicted.
Wow.
It is only predicted if it's on the least squares regression line.
Okay, makes sense, makes sense. Makes
Yep.
sense.
I think.
Okay?
I'm not relearning.
And then simply,
Before I agree.
does the least squares regression line over or underestimate the mass of that bullfrog? It overestimates because it is what is above it?
The line's above
The line, the least squares regression line is above the actual point, or the point is below the least squares regression line. That's why you can't say it, you gotta be clear with your language, okay? So be clear with that, let's see what the rubric says. Oh my goodness, look at all the options for R squared.
Bro had options on him.
Okay,
I didn't read on that.
no, you're good. So, I mean, I do when I score y'all's test, because I wanna make sure it's accurate, but, so you identify the correct bullfrog. Notice it just says a length between 160, 165, and mass between 350 and 375 would be correct. And then you explicitly indicate whether the linear model over or underestimates the mass for the bullfrog identified in part DI, and a correct justification. Now I want to point this out. Why do you think it says it could be over or underestimates? Why isn't it just that the linear model overestimates?
Because you could have picked another one for D1.
Yeah, what if you pick the wrong answer up here?
You're screwed.
This allows them to read with you,
Okay.
right? If you picked a point that was above the linear regression, that means you missed part 1, but could you have gotten part 2 based on that?
Yes.
So always make a decision and then justify off of that. Yes, Lexi?
What was it where half of the points had to be under and half would be over?
Approximate, so for the least squares regression line to minimize those sum of squares, it's going to be approximately half above and half below.
That's what I would do.
But I will point out with this one, is that necessarily true?
No.
Yeah. Do you know why it's not necessarily true here?
Here's 11 points.
Because this is so far away that that sum of squares is going to balance out the sum of squares for these that are really close. Right? That's a good question. So remember, it just minimizes the sum of squares. Visually, like if you were just drawing your own, you would roughly split it though. Okay,
How dare you?
so make sure that you indicate to yourself if you got an E or not, or D. And so notice, Deacon, you were asking about this yesterday. How many parts were scored on this question?
5. Right.
On this question?
There was A, there was B, there was C, and then there was D.
I was kind of D1 and D2.
But notice D1 and D2 are grouped together, right?
Oh.
So if there's 4 parts, and E counts as 1 point, a P counts as half a point. Right? Notice the P here is just you get one of those 2 components. So mark whether you got an E, P, or an I on this one.
I got 3 points.
Or sorry, mark if you got 0, 1, 2, 3, or 4 points. If you got a half, then think about the strength of your response and either round up or down.
I had answered an 8, but I'm 4.
It would have been 4, yes.
For,
Austin.
for B2, would just saying that it overestimates the predicted mass, or what would be mass, not predicted weight?
Well, it'd just be mass, so you would miss part 2, and also you need to explain your answer, right? So guys, make sure that if you look again at D2, you had to explain your answer. You had to either say that the linear model was above that point, or that that point was below the linear model to get that credit, okay?
Just kidding.
Hold on 1 second. Alright, I want you to take 11 minutes to do number 2. Make sure you start with A, Deacon.
Yes, sir.
Where's A? Hey, hold on.
Look,
Hey, you come over here.
Deacon,
I need y'all silently work on number
it
2.
is on the other page.
Number 2. Yep, we're starting.
It's
Number 3. Looks like I'm bored. Go ahead.
We already did 2 before you started.
Alright, let's go over this one. So, again, guys, one thing I always want to heavily emphasize and remind you is this. I don't care where you are with your understanding, I care that you are improving your understanding. Like, take the AP exam out of the equation. One of the biggest things I want you to understand is, it doesn't matter where you are in anything in life, you can get better. Okay? And so hard work pays off. It's important to focus on the growth, not the current placement, right? You never become the best you by just focusing on how quote unquote good or bad you are currently. It's always the eyes on the prize of where we're going to end up, so always chase after better. Ask those questions, improve your understanding, do not settle for where you currently are. All that in mind, let's look at this question. These are things we want to make sure we understand. So a dermatologist will conduct an experiment to investigate the effectiveness of a new drug to treat acne. The dermatologist has recruited 36 pairs of identical twins. Hey, what does that automatically make you think of, or should? Matched pairs test, right? Those twins are going to be very, very similar to each other. Each person in the experiment has acne, and each person in the experiment will receive either the new drug or a placebo. By the way, matched pairs is a type of what?
Design.
It is a part of the experimental design, but there's a part of experimental design that matched pairs is a specific type of.
Oh, blocking.
It's type of blocking, right? We want to remember that matched pairs is a block of 2, and you're going to randomly assign the treatments to one of those 2 people.
What's the difference between stratifying and blocking?
Great question. Do y'all know?
Stratifying is for survey or
studies.
So stratifying is a type of sampling for observational studies. Homogeneous groups. Blocking, again, homogeneous groups, but it's how we randomly assign the treatments. After each person in the experiment uses either the new drug or the placebo for 2 weeks, the dermatologist will evaluate the improvement in acne severity for each person on a scale of 0 to 100. So treatments, what do we mean by treatments? The new drug and the placebo, right? It's the things that are applied, right? Experimental units, huh?
We did both of them this time.
Good, we learned, right? Growth, experimental units. That's what the treatments are.
applied to.
Identical twins back.
So it is the, that's a good question. So it's, the experimental units are what the treatments are applied to.
I mean, they're applied to the twins.
So yeah, I would just
Not
say,
applied directly to the acne.
right, yeah. So I would definitely say the twins. I'm wondering if we need to say the pairs of twins
I said
or just the
36
individual
pairs.
twins.
I said 36 pairs.
Yeah, I did.
So maybe 36 pairs of twins. Usually experimental units, you don't have to actually say the number. Let's check to see what the rubric says. Response variable though is what?
Improvement of acne.
The improvement in the acne severity. All right, so let's check rubric.
That's what E.
Treatment
So
says,
is there 70, there's 72 people.
so notice it is the 72 people who received the new drug or placebo would be our experimental units.
We're saying 36 pairs of twins be correct.
That is a valid question. Let's look at what the notes say, because my guess is they address this. But my other guess is no. Because you're not assigning treatments really to pairs, you're assigning treatments to the individuals within the pairs.
Yeah.
So I would have just probably said the experimental units are the people. Now it does say subjects, participants, twins, so let's find out. And notice response is the severity of acne. So component 2, See, experimental units are the what? Individual people.
But it says it can response could refer to twins too,
Just not usually says.
Well, no, it says the
without.
could refer to participants, subjects, twins. Okay, so they would have taken just twins. Okay.
Pairs of twins does not satisfy.
So if I just mark out 36 pairs, I can just twin by them.
Alright.
I mean, literally, doesn't it
You
contradict?
know, fair enough, fair enough.
Wait, does 36 pairs of twins
If they
count?
think of
Because it says twins is, but then it
So,
also
well,
says.
hold on.
It says twins, but not the pair.
And this is why, hey, listen, guys.
Gavel.
The experimental, so if you say 36 pairs of twins, then you're saying that the pair is what the treatment is applied to, but the treatments are applied to the individuals of the twins. This is why, if you remember on the driveway example, you didn't have to say the 60 driveways, you just had to say the driveways. I would include the context, not the number when asking about the experimental units. The experimental units are the twins or the individuals that are twins, right? But notice you did not have to have the number 72. And so that's a good rule of thumb there is treatments are applied to individuals, not to pairs. It'd be the treatment is applied to an individual. All right. What do we have going on here? Oh, no, this is advantage. It's on part C that we have to describe it. So what's the statistical advantage of using a matched pairs design rather than a completely randomized design?
It reduces bias.
Be careful.
Confounding.
I would say, does it reduce bias or confounding? Confounding, right? Bias is the issue of a sample not being representative of a population. Confounding is that idea of messing up the relationship between explanatory and response. So, but we probably need a little bit more context to it, right?
I said like reduce the confounding of skin type and like severity of acne per person.
So the twins, right? One's twin is more similar to it themselves than a random person, right? So by pairing them together, we are going to reduce the confounding of individual effect.
Hey, don't identical twins have the same genetic makeup anyway?
They have
that's what I-
very similar genetic
Yeah.
makeup. So
I said there's
they have a
no-
lot of context here, right? And I will say, and I like this note, right? Improvement scores will vary due to many factors, right? Genetics, lifestyle, right? Where you live, things like that can affect acne. And so, and even initial acne severity. So those other variables can affect things. That's what we mean by confounding, right? Where you live, your initial acne severity. Y'all remember when we did the matched pairs design with the cholesterol reducing experiment? Right? Your weight, your age, and your initial cholesterol level all affected how much your cholesterol was reduced by. So when we paired, we were able to see those differences more easily. So you had to have a statistical advantage of a matched pairs design and satisfy the following three components, right? So the advantage pertains to an inference made after collecting the data. So we had to distinguish between the effects of the treatment or the precision estimate of the drug effect. So essentially what they're saying is cause and effect, right? By doing that matched pairs design, it improves our ability to establish cause and effect. So you had to, because they do say in comparison to a completely randomized design, right? So the idea is that the matched pairs reduces the confounding, allowing it to be easier to identify cause and effect than a randomized design. And we had to have something about the context. Always have context. So they have a whole lot there. This is probably one that was a little bit harder to get an E on with all the details they wanted. But one big thing we need to recognize is we need context, right? Always have to have some kind of context. Two, if you missed this detail about explicitly comparing to a randomized design, I totally get that. I didn't get to sit down and go through all this, but notice the language specifically says a statistical advantage of using matched pairs design in comparison to a what?
Completely random.
Completely randomized design. So what do you need to do? Answer that full question. Not just say that it reduces confounding, but talk about the idea that twins are most similar to each other. So we're going to reduce the confounding better with a matched pairs design than you would in a completely randomized design, things like that. By the way, I can also send, would you like me after today to send out this
Yes, please.
scoring guidelines?
Yes, please.
Okay. By the way, you know that you can find all these scoring guidelines online, right? I know, it's way too much work, sorry. C.
C was easy. I put unique this time.
Good. Now, we need to be careful with this. For the dermatologist experiment, describe how the treatments can be randomly assigned to people using a matched pairs design. So, in which twins are paired. So what do we need to do?
Label.
So label each
Pair. Twin.
pair or each twin?
Twin in each pair.
You need to label each twin in the pair.
Yeah, I mean, you can start by just labeling the pairs, and you just, I did it differently, because I labeled the pairs and then I separated them, and then in group 1, the eldest person gets a placebo, in group 2, the eldest person gets the new drug, so.
That can work. That might work. Let's see the rubric. It's going to be easier, though, to say that we're going to label the twins in each pair, right? Randomly generate. And so I will say this, you don't have to say unique number when there's only 2 options, right?
Yeah.
That's
Randomly, and so that's what I would do. I would just label each twin 1 or 2, randomly generate a number, and if it's a,
I didn't even know it.
I just did generate 2 and 1.
You can do even or odds, but I mean it's just 2, so 1 or 2, and when whoever gets selected gets the new drug, the other person gets the placebo. There's actually lots of ways to do it. That you we'll look at the rubric in a second, but that's what I would have done. You had to be clear about who's going to get the placebo, who's going to get the new drug. You had to be clear that you labeled and that you randomly generated. I will say, and I'll answer your question in a second, what you could have done is you could have numbered everyone from 1 to 72.
I did.
Randomly generated, 36 unique numbers. Those people get the new drug, and their pairs get the placebo.
Oh, they're pairs.
Right? You see, so like, there's lots of ways to do this, as long as you guarantee that one twin gets the new drug and the other twin
Well, if you
gets
do the
the
1 through
placebo
72,
randomly.
When you do the 1 through 72, you can't guarantee that the 2 people are
Like,
paired.
what do you get, like 30
Yes,
times?
yes, hold up, listen to what I said. Hold on, one more time. Randomly generate 36 unique numbers,
Okay.
I guess, until you get to make sure that it's in one of the twins is selected. You would have to include that language.
Yeah, there you go.
I got you now. To make sure that it's only one of the twins is selected, but notice that second language I said was, and then the other twin gets the placebo. But I'm not saying to do it that way, I'm just saying that's the language you can use. So there's going to be lots of notes on this one, I guess. But look at the way they say this. So they even give 3 different options. And I'm going to go ahead and tell you, they sometimes show these options of like using a coin or drawing names out of a hat. I'm not down for that option. A random number generator is the only way that I think is good. Personally, that's my own personal thing. You can do it. You've learned how to do a random number generator. Just do that. Yes?
Saying use a random digit table would be okay too?
You can. I would just use a random number generator.
Definitely
But
cards.
the one thing about a random number generator again is this: with a random digit table, you're gonna have to think through how are you gonna assign, and I guess you could do evens versus odds. Yeah. But randomly generate 1 or 2.
Yeah.
Yes. Every day, dog.
Why does it say shuffling
Hey.
cards?
Water.
Say
Right.
again.
Why does it say shuffling cards?
So if you look at the third option, it's drawing cards out of a hat or something like that.
That's so stupid.
I agree.
This is not the 1920s.
Okay, but right here, okay, assigns the 2 treatments within a pair of twins and satisfies this. A random process, right? Shuffling cards, flipping a coin, random number generator that gives each twin in a pair a 50% probability of getting the drug and a 50% probability of getting the placebo. Describes how to use the random process to assign one specific twin in each pair to the drug and the other twin to the placebo. and indicates the random assignment process will be completed for each pair of twins. So you had to have those three things in there.
Can you read mine?
Yep. Label each treatment as a 1 or 2, and each twin as A or B. They can use technology to generate A or B, and then maybe assign as a 1 or 2 to them. Let's talk about that,
I gave it to you.
because it's not gonna be an E, but it might be a B. Okay, that's it for that question. We have,
One more question.
we do, except not to then go over it. So, let's do this.
Let's just do it 30.
So we'll just go piece by piece. I'll give you a couple minutes to think about it and we'll go over it, right? So number 3, a machine and manufacturing company is programmed to fill shampoo bottles such that the amount of shampoo in each bottle is normally distributed with a mean of 0.6 liters. Standard deviation is 0.04. Let the random variable A represent the amount of shampoo in liters that is inserted into a bottle by the filling machine. A bottle is considered to be underfilled if it has less than 0.50 liters of shampoo. Determine the probability that a randomly selected bottle of shampoo will be underfilled. Show you what. So, 2 minutes. Do as much as you can with A. Just part A, bro.
Oh, okay, cool.
Next question.
I don't want to do it.
We're on number 3, part A.
I know everything.
H.
This one?
What year was this?
Hmm?
What year was this?
2 years ago.
I could have fallen out on this. I mean, this would go to 5. I
Alright, part A, Lexi, give me one key detail that we should pay attention to with part A to get started on this one.
I was thinking that it was, you're good. Normally distributed, and it gives the mean standard deviation,
So what do we need to do to probably start?
draw distribution.
And a normal one, right? Nice and easy. What's the mean gonna be here?
0.60,
And don't forget, what z-score would that correspond to?
0.
0.5, oh yeah, 0.
The z-score, right? The mean is 0. 1 standard deviation below, what's the standard deviation? 0.4. So then it would be 0.56 or z of -1, right? So you can keep that going. And I think so remember, personally, I always recommend converting to a z-score. How do I calculate a z-score, by the way, Bryson?
That was mean of standard deviation.
So what's my value here?
0.5 minus 0.6 over 0.04.
Now, why am I not dividing by a square root of n here? It's just one, right? It's not a sampling distribution. It's one shampoo bottle that we're looking at. If I remember correctly, was it negative 2.5?
Yeah.
In this case, I think they get the same probability too.
Yeah, it would. You just don't have to. Does it matter if I do less than or equal to? No, right? Remember, with a continuous distribution, this is what you were asking about yesterday, Lexi. With continuous, the area is 0 at that one point, so it can be less than or equal to. Notice that language, though, the probability notation I have here is it's the probability of this is equal to the probability. I don't do probability of the probability. What's the value? Was it 0.006 something?
621, 0.00621.
Typically 4 decimals is all you have to do, but you can definitely go more beyond that if you want. Deacon, what were you going to ask?
I did the probability of A is less than 0.5 liters. Would that be right too, or that?
Only if, I mean, so yes, if you use A, right? Did you get that same value?
Yeah.
Did you use that normal distribution?
Yeah, all right.
I
Just
think
my
you have to
probability is
define
right
it.
different.
That's perfectly fine. I just converted to a Z, so I did less than, Z is less than. Yes, Austin?
Would putting the probability of a shampoo bottle being underfilled,
Say that one more time.
would just saying the probability of the shampoo bottle being underfilled be okay?
Like saying it like that instead of using that probability notation? Yeah.
Okay.
Oh, yeah, using that language. So, use of a normal distribution identifies the correct parameter values. Notice you can identify those correct parameter values either on the curve itself or by doing a curve and then a Z. Specifies the correct event, boundary line, and direction, so to the left, and the correct probability. Or at least probability consistent with component 1 or 2. So we want to make sure when we get to that normal distribution, we quickly, right, draw out that z-score, quickly draw that normal curve, and get it going from there. All right, so B. After the bottles are filled, they are placed in boxes of 10 bottles per box. Pause. What should we instantly think about now?
Sampling distribution.
Sampling distributions, right? We now are looking at samples of 10, so more than likely a sampling distribution. But let's see what the rest of the language says, because it may change our mind in a second. After the bottles are placed in the boxes, several boxes are placed in a crate for shipping to a beauty supply warehouse. The manufacturer's company's contract with the beauty supply warehouse states that one box will be randomly selected from a crate. If 2 or more bottles in the selected box are underfilled, the entire crate will be rejected and sent back to the manufacturing company. Okay, reading that language, do we still think sampling distribution?
No.
Oh yeah, it's either underfilled or it's not, right? Think about your bins,
So rejected, or would that also work?
right? So binary, rejected, well, we're rejecting the whole crate or the whole shipment based on the bottles, right? So, but do we have independent trials?
Yes.
Yeah, one bottle should not affect the next. Do we have a fixed number of trials? Yes. Do we have the same probability every time?
Yes.
By the way, I do want to point out, if you did not get part A right, but you used that probability in part B, would you be okay?
Yes.
So if you can't do A, make something up for the probability and use that in B.
So for
So I
N,
think the
would it
random.
be 2 or 10?
Hold on, I got 2 people talking.
So for N, would it be 2 or 10?
That's a great question. Would N be 2 or 10?
And would be
It's
10.
2.
It's the number of
And would be
trials. How many total trials are there? 10. Notice this would this be a binomial PDF or CDF? CDF, it's 2 or more, right?
So would the probability be 0.00621 squared?
Think about the fact that it's a binomial. Look at your formula sheet see if there's anything about binomial and use your calculator. Couple minutes to wrap up these next pieces.
I'm just trying to find out.
But the calculator, knowing it's binomial, tells you what to do, so does the formula sheet.
So I think the random variable would be underfilled or not underfilled.
It's how many are underfilled.
This is something.
It's the binomial random variable.
What's our probability of success?
Remember, it's from part A, right? Well, it depends on what you consider success.
I'm gonna do.
We're rejecting if it's underfilled, which doesn't really feel like a success, but that's what we consider a success.
Brace yourself for impact.
Could you consider just like, oh wait, no, you can't, never mind.
This little baby there.
I know, are they like
So
white,
number
yellow,
of
green?
models would be the.
I thought they were.
So, yeah, the defining of the variable is sometimes hard. So it's a binomial distribution for the number of underfilled bottles. So right here, this is where I need y'all to pay attention because I'm pretty sure, I haven't checked the rubric yet, but do you remember what defines every binomial distribution?
Bands.
Well, that's how we check to see if it's binomial. But if we're defining a random variable, defining the binomial distribution, what do you have to have?
Discrete variables.
Yes, it is discrete, but there's something that we actually have to put here. There are two values that we have to put.
In and.
So the number of trials and the probability of success. With 10 trials
Could you also just say with n equals 20?
and with, well, n equals 10, right? And a probability of success equaling 0.0062.
Is that the random variable of
You
interest,
could
or is
say
that just a
with n
definition?
equals 10.
That's defining the random variable of interest, right? And state how the random variable is what? Distributed. So it's a binomial distribution for the number of underfilled bottles. There's my random variable with 10 trials and the p of 0.0062. Now I could find my expected value, my standard deviation, but I think that's all they need for a binomial.
I thought they wanted you to say it's like skewed, right, or something. That's what I got.
So if we're talking about random variables in probability,
Yeah.
they want to know continuous, they want to know discrete. If it's binomial or geometric, they want to know that.
Okay.
Yeah.
Lower bound is 2.
They may want that. I could be wrong, but I'm pretty sure that's it. Huh?
Is that capital P? You're right.
Yes. I didn't write it that way, but yes.
Probability
Like they
of
say points off.
Okay.
How do you show work?
Yeah, it's a great question. How do we show work here? Well, it's a probability, right?
You show what you
So
use
you
technically,
use
right?
the
You can do that.
distribution equation.
So I would use my probability distribution equation. All I would do is I would do 10 choose 2 times 0.0062 to the second times 0.9838 to the eighth plus plus 10 choose 10 times 0.0062 to the 10th times 0.9838 to the 0. Because it's 2 or more, right? So,
Don't you have to do one for every single one?
Do you know the answer for that, Michigan?
off the top of my head, no. In the calculator, sure.
No, I'm saying do you want it?
Oh, I was going to just pull up the rubric in a second so we can check ourselves. But what I will point out is this. That's not the only way you could have done it. Does anyone know another way I could have written it out? Well, yes, and maybe show some of the things in the calculator. But I was just going to point out, couldn't I have just done the complement, right? 1 minus 10 choose 0 and 10 choose 1.
That's pretty cool.
Right? It's all, the complement idea works there as well.
But don't you have to write the sum of that?
Well, notice by doing 10 choose 2, this plus ... all the way to the end, I have done that.
So do you take one, wait. Do you do each one for the N or each one for the X?
For the X, the number of trials stays the same.
That true.
The number of underfilled bottles is what I continue to
Number 2 and 1.
Okay? So, notice right here, hey guys, defines a random variable as the number of underfilled bottles in a box of 10 bottles for part B1. Indicates the random variable has a binomial distribution with n equals 10 and p equals 0.0062, or whatever from A. And notice that was also for B1. So notice, Ashton, it could have been in part B1 or B2, but you had to say somewhere, indicate somewhere that it was binomial with n equals 10 and p equals 0.0062. That's what they mean when they say the distribution of the random variable. So when they talk about random variables and probability, they're talking about what type of probability and what are the defining characteristics. So if they want to know how is a normal distribution, or a random variable distributed as normal, you need to say it's a normal distribution with a mean of blank and a standard deviation. Okay? Yes,
If
Peyton?
I said 0.0167, would that be close enough to?
Probably just routing, right? So then notice 3, supporting work of some sort, and 4, correct probability. If you only had 2 or 3, notice you could have gotten a P there. So,
A lot of work.
there's a lot there for component 2. Why would you do that? You could do even just words or standard notation. You could use calculator function notation to a certain degree, but notice sometimes it does not satisfy. Hey, tonight, I need you to finish, listen, I need you to finish number 3, and I need you to do number 6. Hey, which questions I need you to do tonight?
3 and 6.
Finish 3 and 6. Right? 6 takes a lot of time in person. That's why I'm asking you to do that at home. We'll continue. Hey, would y'all rather do more free response tomorrow or do some multiple choice tomorrow?
Probably,
Well, we only have so much time.
Okay.
Raise your hand if you want multiple choice tomorrow.
Absolutely.
Raise your hand if you want free response tomorrow.
I do so good.
Alright, so here's what I will do. We'll do free response in class tomorrow. I will assign multiple choice to do over the weekend. We'll go over it on Monday. Oh, hey guys, I'm so sorry I forgot. We have to do presentations tomorrow.
Yeah.
If your partner's not going to be here tomorrow, then your presentation will be on Monday.
What are we presenting?
The projects.
The study design stuff.
So, if you need to come in at some point, look at those projects to remind yourself of it. But we're doing presentations tomorrow. Say again.
Yeah, I had to get some more water.
I'm not legally required to be here, but hey, if you like walk.
Tyler.